Without further ado, welcome officially to this international conference organized by Lithuanian Research Centre for Agriculture and Forestry. It's lovely to see such a global audience gathered here today to celebrate EU Green Week, find out how research can contribute moving towards zero pollution, and most importantly, learn about the brilliant research that is taking place at Lithuanian Research Centre for Agriculture, Forestry, and their partner institutions. My name is Aurelia Povilaitė, and I will be your host for today. During today's event, which consists of 3 sessions, probably you have seen the agenda, but if not, we're going to post it as well, you will hear from 15 brilliant international scientists and qualified specialists on the subjects of the healthy soil, crop diversity, and reduction of synthetic pesticides and fertilizers. I would like to encourage you all actively participate and post your questions in the chat box. We will aim to answer them during the presentations and after. I would like to ask presenters to keep their microphones muted and close all the unnecessary browser tabs to improve your connection. Just to let you know that this event will be recorded and recording will be shared with you after the event. And without further ado, I would like to invite Dr. Gintaras Brazauskas, Director of the Lithuanian Research Centre for Agriculture and Forestry, to open this international event. Gintaras, the floor is yours.
Thank you, Aurelia. Good morning. Nice to see you all here at this event. And let me just start my welcome speech. So dear guests, participants of the conference, dear Minister, Vice Minister, and colleagues, it is my sincere pleasure to open this event, which is part of the EU Green Week initiative. Officially, Green Week will kickstart on Monday, and the whole week will be devoted to discuss pathways to a healthy planet by achieving zero pollution for air, water, and soil. Zero Pollution Action Plan is an integral part of the very ambitious goal European Commission has set to the EU by announcing Green Deal in December 2019. And this goal is very clear. Europe is set to become climate neutral by 2050. Of course, there are lots of opinions what is the best way to achieve this ambitious goal, and this is a very healthy discussion which breeds new ideas and raises overlooked questions. However, we all have to be honest to ourselves and admit that there is no other way to preserve this planet for the future generations. Agriculture and forestry contribute a lot, both to the drive and mitigation of the climate change. We have to reinvent the way we tackle natural resources to tip the balance to the mitigation side. Here, we will need all the technologies available, as well as new innovations. Biotechnologies and digital technologies, to name just a few. Science should be at the frontiers of this drive. I'm really happy today we have a chance to discuss some of these ideas we are developing together with our partners within Europe. Special thanks to the presenters from France, Greece, Sweden, and Norway. We value your partnership and look forward to the exciting collaboration in the future. Finally, I would like to thank representatives from the ministries for taking part in this event. The innovative role of the research was clearly demonstrated during the pandemics by the development of new vaccines in a record-breaking time period. Now it is time to find a cure for a planet, and we will not succeed without fostering science. Even small countries or institutions can do a lot if they stand together on the right path. Thank you.
Thank you very much for such an insightful welcome speech, and at the same time highlighting the most important things and why we're here to make an impact today, tomorrow, and for the future generations. And now I would like to invite an accomplished agronomist, phytopathologist, and vice president of the Lithuanian Academy of Sciences, Professor Zenonas Dapkevičius, to say a few words. Professor Dapkevičius is not only an accomplished and renowned researcher and educator, his innovative methods helped to develop plant protection systems against diseases and pests in Lithuania. I'm sure, Professor, you have quite a lot to say on this topic, so floor is yours.
Thank you very much for a very nice introduction. Thank you. Good morning for all conference organizers, presenters and guests. First, thank you for invitation to participate in this ambitious conference. In fact, it is a major to have efficient agriculture and forestry production at the same time and to achieve zero pollution. Always at the beginning, they set high goals seem very ambitious and not available, but after greedy thoughts, desires, scientific discoveries, the use of good practice, great results can be achieved. Practical experience has also shown this. Throughout the progressive world, including all Europe and Lithuania as well, great efforts have been made to reduce pollution from agriculture and forestry in recent decades. New agriculture technologies, advances in plant breeding, smart technologies, integrated plant nutrition and protection help to make agriculture and forestry more environmentally friendly. But we cannot stop on achieving intermediate results in this area. So we must strive for the lowest possible environmental pollution in the future. It is a fact that agriculture, and especially intensive, has some negative impact of the environment. But there are many other areas of our lives and activities, including transport, energy, industry, which are characterized by high levels of environmental pollution. Thus, from the Lithuanian Academy of Science, I want to express my concern that we must address the issues of environmental pollution reduction not only in agriculture and forestry, but in an integrated way in all areas of life. Today's conference presentations and topics show that researchers are looking for solutions to develop environmentally friendly agriculture and forestry in both international and national projects. I firmly believe that together scientists, policymakers, farmers, and other producers will find the best solution how to go in this direction. Thank you very much for attention, and I wish all participants a good and productive conference. Thank you very much.
Thank you very much. And actually, just to highlight that to reach zero pollution, we need to co-develop and co-create strategies with different stakeholders. And as Gintaras and Professor Dabkevičius mentioned, we need various representatives from ministries, citizens, and other scientists. So I'm very pleased to invite Mr. Gintautas Jakštas, Vice Minister for Education, Science and Sport, who is here with us today to give a welcome speech. Mr. Jakštas, the floor is yours.
Thank you, Aurelia. Good morning, dear hosts and participants of the event. Firstly, I would like to congratulate all of you who have gathered to this important event dedicated to zero population in agriculture and forestry. We can see how important this conference is. Participants from around the globe are gathering more than 1 hour before the start. The present global use of resources is sometimes causing severe damage to the environment and biodiversity and is changing the world's climate. Air, soil and water has in many regions been polluted. The costs of this environmental damage as well as costs of the negative social consequences are huge and painful. The sectors of agriculture and forestry can be used in reversing present trends. Sustainable technologies offer possibilities for improving air, soil and water quality and could help preserve biodiversity. These sectors also provide renewable raw materials that can replace the polluting fossil raw materials for industry and the energy sector. In this context, we have emphasized the importance of the EU instruments, the EU Action Plan toward Zero Population Ambition and the European Green Deal. These instruments will also support the post-pandemic recovery by helping to rebuild a more sustainable EU economy, creating job opportunities and reducing social inequalities. We can do this by turning climate and environmental challenges into opportunities. So please accept my best wishes for meaningful sessions and fruitful discussions. Thank you very much.
Thank you very much, Mr. Yakstas. Yes, that's very true. We need innovation. We need the interdisciplinary working to achieve the results. And now I would like to invite the Head of Crop Production and Agri-Environment Division at Ministry of Agriculture, Mr. Vaidotas Ašmonas, to say a few words. Are you with us?
Yes, I am.
Hello.
So, hello. Yeah, good morning, ladies and gentlemen. And then I see dear 140 participants of the conference. So my name is Vaidotas Ašmonas, and it was presented as a very difficult name of my department, kind of Sustainable Agriculture Production Policy Department. And first of all, I'm pleased to convey the sincere wishes from my Minister of Agriculture, Kęstutis Navickas, who is in Brussels today, to the organizers and attendees of that conference. The topics covered at that conference, such as a healthy soil, the background of planet survival, the importance of crop biodiversity, and reduction of synthetic pesticides and fertilizers, are of particular importance in raising awareness of shaping long-term oriented agricultural policies. So we are glad that there is insightful scientists in Lithuania who, for many years, with factual evidence, call on us policymakers to orient agricultural activities so that we can stop soil degradation, take measures so that biodiversity, which is vital for agricultural activities, has favorable conditions to provide their services. I could give you example like that United Nations, that according to United Nations, erosion is destroying up to the 2/3 of the world agricultural land, reducing agricultural productivity. According to the FAO, 80% of crop yield is determined by the soil quality and only 20% by the other factors. So the world geologists have estimated that more than 700 million tons of fertile soil are washed from the planet each year. In Lithuania, almost 70% of soil are severely damaged by erosion, and the consequences of it could be that the production can become uncompetitive due to the increase of costs and harmful residues. In areas affected by erosion, plants grow less or even disappear completely. In eroded soils, about 40–60% of plants are lost, but in such a case, we usually write off losses due to the inefficient fertilizers, drought or other factors, but not erosion. So the global assessment of biodiversity and ecosystem services published by 500 scientists and experts from 50 countries in 2019 showed that the global ecological situation is in a crucial stage. According to the preliminary estimates, about 50% of agricultural land may need to be returned to the nature. The conversation of biodiversity equates to the importance of the issue of human survival, which is also closely linked to the climate change. Farmers lack knowledge about soil degradation and importance of the biodiversity for the success of their economic activities. So we see that sustainable farming should be mandatory, but number of farmers tend to produce only what gives is instantaneous profit, paying no attention to the condition of the soil. It's estimated that water erosion in Lithuania destroyed about 10 million tons of soil annually. In order to preserve soil and biodiversity, it's necessary to apply farming methods with plowing, various greening, and environmental measures. We must carry out reliable monitoring of the effect of measures throughout Lithuania. The soil are key to the delivery of wide array of ecosystem services, including water, nutrient cycle regulation, food fiber production, providing a physical basis for construction habitats for various species. We have to develop an inventory of existing upcoming policies, instruments to carry out cross-policy analysis, examining coverage of soil threats and functioning in agricultural policies. In our national climate agenda, in the National Progress Plan for 2021-2030, in the other strategic documents of the government of the Republic of Lithuania, we emphasize that the main goal in the field of agriculture is to ensure that sustainable use of natural resources, sustainable use of wet water and soil, and create favorable conditions for development of biodiversity. So by finishing, I could say that the man cannot control the atmosphere and the oceans, but he can control his economics, production, social action, and force the pessimistic prediction of soil biodiversity and climate change never come true. So we believe that today's reports will deepen our insights, which will help us realize potential benefits of sustainable farming, not only for society, but also for every farmer. So I wish the conference a fruitful work, and thank you very much.
Thank you, Mr. Ashmanas. I mean, the figures that you have provided are absolutely staggering. And I think this, as a part of the work, as we talked about, is a co-creation and information of the society as well, what needs to be done. So everybody is working towards the same goal. And now I would like to invite Vice Minister for Environment, Danas Augutis, to close the welcoming speeches. Are you with us today?
Yes, hello, dear colleagues. Yes. I'm very pleased to say an opening word to the participants of this conference. Both agriculture and forestry are already undergoing changes related to the European Green Deal. Some of these changes people see as a threat, while others see as opportunity to improve and increase importance of agriculture and forestry to our daily lives. Both sectors play major roles not only by providing products, but by providing vital ecosystem services such as soil, water, and others. The European Green Deal, the biodiversity strategy from field to fork, and other documents and their implementations are creating the need for new scientific knowledge and its practical application. We have challenged to preserve biodiversity, soil, and water while ensuring the level and value of the products we supply and well-being of the people who create them. After reading the program of the conference, I see the large number of researchers who will make presentations on these topics. So I wish you a good conference, new ideas, and opportunities to implement them. Thank you.
Thank you very much, Mr. Augutis. Well, the conference and event is officially open, and it's time to hear from the excellent scientists. And I invite Professor Claire Chenu to open our first session on the theme of healthy soil. Professor is conducting most of her research at Agrotech and has always been interested in soil, organic matter, which is essential for food security, the fight against the climate change, and biodiversity. Professor, brilliant, thank you here with us.
Good morning. Do you hear me? Do you hear me?
Yes, we can see you and we can see your presentation. You're good to go.
Okay, thank you. So first, I would like to thank you for the invitation. Well, thank the Lithuanian Centre for Agriculture and Forestry Research for this invitation to this event. I'm really glad and proud to participate to the EU Green Week. I think it's an important event. And so what I want to today is to tell you about knowledge building and implementation on climate smart sustainable management of agricultural soils. So first, the first thing I would like to recall is that soils are absolutely essential to our human societies because they provide many ecosystem services. Of course, the provision of food, fiber, materials, biodiversity support, water regulation in terms of quantity and quality, erosion and disaster control. These has been referred to in the previous presentations. Element recycling and nutrient provision and wastes recycling. This is the topic of the event today, and carbon sequestration and greenhouse regulation. So soils are essential, and soils are also key to the European Green Deal. Here is a presentation of the different components of the EU Green Deal provided by the Commission. And I would like you to notice that soils are really present. Soils are really present in achieving climate neutrality, the biodiversity strategy, in the circular economy action plan, the zero pollution Europe, farm to fork, and towards a modernized and simplified CAP. Soils are essential, are key to the Green Deal. And what I would like to state, are key, and two examples of two targets, a series of measures in relation to the zero pollution ambition that is the topic of today. You see that among the targets of the EU Green Deal, there's the idea to reduce the use of pesticides in agriculture with very ambitious targets, reduced by 50% the use of chemical pesticides, and also that of the most hazardous ones. The second part of this zero pollution ambition concerning soils concerns the excess of nutrients, and targets, again, very ambitious, are to reduce nutrient losses by at least 50% and reduce fertilizer use by at least 20% by 2030. And 2030 is tomorrow. So how are soils concerned? What I would like to show you is that soils are concerned in the Green Deal in that they are involved in achieving the Green Deal, but they also benefit from the Green Deal. Let's consider, for example, a 20% reduction in fertilizer use. One of the consequences that may appear for soils is a reduction in soil acidification, and this is beneficial. Now, how to do that and how to reduce nutrient excess also? There are three categories of levers: improving the provision of nutrients by soils themselves, by increasing soil organic matter content, mycorrhiza, legumes in the rotations, by substituting mineral fertilizers with organic fertilizers, and by trying to avoid nutrient losses. And these can be performed through integrated nutrient management, rotations, appropriate rotations, cover crops, agroforestry, precision agriculture. You see a wide range of management options. And if these management options are implemented in order to reduce the excess of fertilizers and the nutrient excess, then it will have consequences on soil. So you have additional indirect benefits to soil by increasing soil organic matter, resulting in increases in soil biodiversity, increased soil structure. So increased provision of ecosystem services behind. But there are still knowledge needs. Although the management options are known, there are still knowledge needs. And a few examples, I'm not exhaustive here, but for example, regarding I'm keeping with the fertilizers and nutrients, regarding agroforestry, the soil nutrient dynamics and cycles are not that well known. So this deserves knowledge development. Regarding the balance of carbon, nitrogen, phosphorus, sulfur, soil stoichiometry, what are the consequences in terms of organic carbon sequestration and dynamics? And okay, replacing mineral fertilizers with organic fertilizers, there's wide, this is really an opening, but do we have a typology of organic wastes? Do they all have the same effect on soils? These are research questions, knowledge developments that are needed. And to be synthetic, what is needed is to develop sustainable management of soils, and in particular of agricultural soils. And FAO has defined what is sustainable soil management. So soil management is sustainable if the supporting, provisioning, regulating, and cultural services provided by soil are maintained or enhanced without significantly impairing either the soil functions that enable those services or biodiversity. And FAO has provided voluntary guidelines for that. And so in a sense, sustainable soil management leads to soil health, because soil health is the continued capacity of soils to support ecosystem services. And in the European AJP, European Joint Programme Soil, that I'm coordinating and to which our Lithuanian colleagues are participating, our aim is to foster climate smart. Climate is a huge ambition, a very important climate smart sustainable management of agricultural soils. And for that, I think in terms of knowledge, what is needed is knowledge development. And I gave you examples of knowledge development regarding agroforestry, stoichiometry, for example, organic wastes. So this is clear. Knowledge development is needed, but that's not enough. That's not enough. What is also needed is knowledge sharing and transfer with the different actors, with the different stakeholders. Knowledge harmonization, organization and storage, soil information, soil data is becoming increasingly crucial. So we need to harmonize it. We need to define how to share it with rules, not, yes, we do. We need to proceed with rules. We need to harmonize. So we need to be able to have data sets that help us to manage soils. And of course, we need also knowledge application and tools for knowledge applications, such as long-term experiments, such as shared knowledge, shared co-construction of research programs with the different stakeholders. So all these aspects of knowledge are needed if we want to foster climate smart sustainable management of agricultural soils. I would like to show you what we did in the AJP soil this year. It's a young program. We started 1 year ago. There are 24 European countries who joined it. What we did first was to build our own roadmap. And for that, we performed during this first year stakeholders consultations. We had national hubs. Maybe some of you have participated, and if it's the case, thanks a lot. We also performed literature reviews, and we also performed systematic inventories across the 24 European countries on different topics. And what we wanted to identify related to agricultural soil management were what are the aspirations in terms of what are the priorities, the problems seen as being the most important, what is the vision regarding policy, because policy is there to answer, to help achieve a challenge. Also, what is the knowledge availability on different topics? What is the knowledge use on different topics? Remember, sharing knowledge. And what are the barriers and opportunities for implementing climate smart sustainable soil management? And this we performed, so we built this whole consultation and analysis of available documents and of the state, the baseline, the state of the art, in order to identify knowledge needs. And then we are a research program, so we will be able to organize calls, internal calls, external calls, to try to answer to at least some of these research needs. But the roadmap can be useful also for others. The framework that we used is the following. You see goals, soils, management. Soils, they are important soil functions. They are related soil challenges. So for example, for the topic of today, enhanced soil nutrient retention, enhanced nutrient use efficiency. There are goals, climate change mitigation and adaptation, sustainable production, enhanced ecosystem services, soil restoration, and less degradation. And there is, in relation to soils and to agricultural soils, our object of research in the AJP soils are agricultural soils, their management. And so we defined a series of elements of what could be climate smart sustainable soil management. So you see, for example, improved nutrient management, control erosion and land degradation, improve water storage and water use efficiency, and soil organic matter management and carbon sequestration. So this is the framework we worked with, and I would like to show you a few results from this European-wide consultation and show you on one topic how we translated that into knowledge needs and actions. So first, we asked what was the perception of the importance of challenges for agricultural soil to the AJP soil stakeholders from our national hubs, and more than 350 stakeholders belonging to different categories that you can see here, very varied categories, answered to our questionnaires. And the result is here in terms of percentage of scores. They had to distribute, they had a score of 100 to distribute between the different challenges. You can see that the challenge that was recognized, well, identified as being the most important for stakeholders consulted are to maintain and increase soil organic carbon. And these can be explained by the very central role of soil organic matter in soil functions and ecosystem services. But in relation to the topic of today, you can see that the second one is to enhance nutrient retention and efficiency, while avoiding soil contamination was ranked less important by the stakeholders consulted. So we had, this was very important for us, a classification of the perception of the importance of soil challenges in very contrasted settings across Europe in terms of pedoclimatic conditions, but also in terms of agronomic systems and even social organizations. So this was very helpful for us. Second, we asked the stakeholders to evaluate, give some kind of an appreciation of the available policies, public policies regarding these different challenges. So you can see again here ranked the different challenges: optimal soil structure, maintain soil organic carbon, and you have, well, here enhance soil nutrient retention and use efficiency, avoid contamination here. And what we asked them is what was their perception of the gap to realization of the policy, and you can see that except a few ones, we are far from achieving more than halfway. And now we asked them whether the current policy in the different countries, so 24 European countries, whether the different policies were ambitious enough for our future. Because we know that climate change is ongoing. We know that globalization is on place. So many things are changing. And you can see again that most policies were evaluated by the stakeholders not to be future-proof. So there are progress needed in implementing our current policies, but also designing more ambitious policies. And the stakeholder view was that generally there is an urgency for policy updates because the current policies considered unable to tackle the prominent soil challenges. So we want to develop a soil science to policy interface. We began with different workshops, and this will be an important activity. We also asked them about barriers and opportunities for implementation of climate smart sustainable management and for developing knowledge needed for that. And so the stakeholders identified a series of barriers. For example, you can see that there's not enough networks among the actors. Regarding knowledge development, that there are not enough public-private partnerships. Regarding knowledge storage and harmonization, there's a lack of common data policy that prevents sharing the data. And regarding knowledge application, that implementing new practices is often seen by practitioners that as resulting in lower yields and profits. So this is a problem. Now the stakeholders also identified a number of opportunities, and again, they are classified regarding whether it's knowledge development, storage, sharing and transfer, application, and a few examples. Awareness of soil in society is really an opportunity, and I think the fact that the Green Deal is that there are events related to soil in the Green Deal is a sign. Ongoing methods standardization, especially through FAO, is also an opportunity the development of transdisciplinary research also, and we do need research that associates social sciences and more biophysical sciences, agronomy, soil science. We absolutely need that to get social scientists, to get economical scientists involved in soil management. And also an opportunity is the increasing idea to develop tailored management strategy, not the same fits all, but really target the different pedoclimatic, agronomic, and social conditions. So we had also this vision of there is an opportunity. And from that, our program aims to provide long-term alignment of agricultural soil-related research at EU scale. We have different expected impacts, and maybe I will only describe the first one: understanding soil management for climate change mitigation and adaptation, sustainable agricultural production, and sustainable environment. So really the question here is how can soil management lead to multifunctional soils? We absolutely need multifunctional soils. And the difference, but we also have expected impacts related to strengthening scientific capacities and cooperation, or developing region-specific fertilization practices. So this aims to help implement and realize the different policies, CAP, climate targets, the SDGs, and support farmers and the farming sector as stewards of land and soil resources. What we're doing in the AJP soil is a wide range of activities: internal calls, external calls, stocktakes, that is systematic inventories. I also told you about science policy dialogues. We also have training with work on harmonization on soil information, and of course we will deliver a wide range of deliverables. I would like, from this consultation we made across Europe, and all the work also of literature analysis, of brainstorming with the different 24 representatives from the 24 partners, and with our different advisory committees, to show you what, in terms of knowledge development, what do we identify. And let's take just the example of this expected impact that relates to multifunctional soils. What we need is to have evaluated soil management options that allow to have multifunctionality. We also need methods, and what we need is frameworks and tools to assess soil multifunctionality and soil ecosystem services. Regarding management options, what came out of our roadmap is that some management options are really in need of additional knowledge, while others are better known, that we need not only to consider individual agricultural practices, but also whole agricultural systems. That we need not only to consider the plot scale, but also the landscape scale. That we need to consider not only the present climate, but also how soil threats will change in the changing climate. And so we need to have this prospective view, a vision of soil futures. And from that, so we have a series. The names are not important here, but to show you, we performed a series of stocktakes, systematic inventories. They are or they are ongoing. They are in purple. We have research projects in green, and we have research topics at the current calls. For example, specific management options deserving more knowledge development, and this is related to nutrients and contamination, are exogenous organic matter. And we will have a whole series of projects related to assessing soil indicators and assessing ecosystem services. And to strengthen that, we develop a network of long-term field experiments, the access to research infrastructure, and harmonize and available soil information. So this is to show you how a research program that associates 24 countries is making a state-of-the-art consulting stakeholders and translating this into identified knowledge needs. Of course, we're not addressing all the knowledge needs. We had to make a priority and implementing that with different type of activities. So to conclude, in a nutshell, I hope that the message I conveyed are that soils and agricultural soils are essential to human societies. that they are key to the European Green Deal, that the objective is climate-smart, sustainable soil management, multifunctional soils. That for that, not only knowledge development is needed, but also knowledge sharing and transfer, knowledge organization and harmonization, and knowledge application. And that so I'm very glad I had the opportunity to present us our program. So it's a H2020 research program for long-term alignment of agricultural soil research at the EU scale. And that the European Roadmap Reviews consultation show the baseline and priorities for developing and implementing knowledge for climate-smart, sustainable soil management. And from that, I would like to thank you for your attention.
Thank you very much, Professor. That's been absolutely incredibly knowledgeable, insightful presentation. Just a very quick question before we move on with our presentations. You talked about, obviously, about this framework in 24 countries being involved and gaps and barriers you have identified throughout the project. And I wonder to what degree now you're thinking of involving citizens or citizen science in future projects, because one of the barriers you mentioned is communication and lack of public awareness. You're doing this amazing work that is going to contribute to the policy and create frameworks. But what about citizen science? How you're planning to reach those farmers who are, you don't have access to the policies? I wonder if you have any insights or maybe thought about the next project on involving citizens.
Yes, well, what I can tell you is that regarding the current call, we have a recommendation for all projects to develop on-farm research, especially in a co-construction mode, whenever possible. And for that, we are developing on the idea of the soil mission. You know that there's a mission on soils, on healthy soils, that recommends to develop living labs. So we cannot implement living labs ourselves, but we try to convince our scientists to use the existing living labs, and maybe their cooperation will lead to new living labs. And we also want to have, in a future call, we want to address citizen science per se. What makes a citizen science project on soil successful? How to use it? Because it's a new way of working for scientists as well. I agree with you that it's extremely important. I think it's very powerful, but we need to do it right. So we want to, think about how to do it at best.
Thank you very much. If you still have any questions for Professor, please put them in the chat and we will hopefully be able to answer them after the presentations. Thank you very much. Thank you. And now I would like to invite Dr. Virginijus Feiza, Head of Soil and Crop Management Department and Chief Researcher as well, who has an interest in the research fields of soil quality and sustainability, soil physical properties and soil management, to do a second presentation. Virginijus, you with us?
Yes, I am. I am trying to share my screen.
Thank you.
Do you see me?
We can see it. You're good to go.
Okay, thank you very much. Dear ladies and gentlemen, it's a great honor for me to make presentation titled The Influence of Soil Management Systems on Soil Quality and Crop Productivity. I will start with a historical picture which has been taken in 1914, and it shows the real situation of Lithuania at that time. And I think it's clear for all of us that our morinic origin soils were not so rich, very stony, and actually had quite low yielding capacity. And there are data for crop yielding of that time. You see the data of different crops, the yield before the World War I. So it's clear that the soil was really how to say, poor, and yields were lower than 1 ton per hectare. And it's very similar between winter and spring crops. Lithuania has different landscape. In the western part of the country, we have upland, and we have another upland in the eastern part of the country. And in the middle, we have so-called Lithuanian lowland. And these are the most rich soils situated here, and they are used very intensively for agriculture. And on the left-hand side, you can see the hill rolling landscape. So it's clear that now the situation changed very much compared to that picture that you have seen. And the average data of crop yielding of the last year, you see that yield is much higher than it was many years ago. But some farmers even harvest much more grain. Let's say for winter wheat, we harvest in central Lithuania about 8 to 9 tons of the grain. Lithuania has also some problems concerning soil use and management. As Claire has said today, we have also problem with soil organic carbon. We have problem with soil compaction, plant nutrition, soil water, acidification of the soil, and of course, reduction of greenhouse gas emission. I will talk about the soil tillage concerning these topics listed before. According to Eurostat data, as you see, the conventional tillage prevails in many countries of EU. In Lithuania, the plow tillage occupies about 90% of the tillable area, and direct drilling, for example, stays only for 1%. And in total, we have about 10% of reduced tillage application in Lithuania. Tillage depth is also very interesting during the history. It changes, as you see, in 1920 from 15 to 17 centimeters. And later on, we used very intensive soil management. And by the year 2000, we had about 40 centimeters plow layer. And now we have idea to come back again to the topsoil and take care about this very shallow soil layer. So the gap of knowledge arises this question: what will happen in the future with deeper over soil layers? Reduced tillage has its own pros and cons, and the tillage is actually used primarily to cut costs of tillage, to save time and labor, and of course to save water. Our results shows that very clear water saving after no tillage and reduced tillage, is in the very shallow top layer, starting from 5 to 10 centimeters. But if we go deeper, the soil moisture content is reducing by going the deeper the soil layers. So it also should be said that superiority of reduced and no tillage is significant only at early stages of crop growing period. And another important thing is that subsoil texture plays very important role if we want to save water. In the case, if we have lighter texture subsoil, so in that case, soil moisture may not be saved as we expect. Another advantage of plowless tillage may be pointed out as soil organic carbon sequestration, accumulation in the topsoil layer, and also accumulation of available plant nutrients like phosphorus, potassium at the 10 to 12 centimeters soil depth. But it has also some gap, because if we have very dry growing season, the soil nutrients may become locked by the soil due to lack of water. So we mentioned this in our long-term field trials here in Lamps. One more disadvantage of reduced tillage is still a risk of soil compaction, and this happens in the topsoil layer. All of us know about the plowing pan, which is about 20-25 centimeters depth, but we have a new phenomenon. At 10 to about 12 centimeters, so it's so-called cultivation of pan formation. So it's actually said it's not good news for farmers, because it can hamper water movement, as rain, water, or even to rise up from deep soil layers. For farmers, it's important to have stable crop yielding, and this slide shows that we have quite different variation of yielding data compared to plowing in different years. As you see, the crucial factor of reduced tillage, and especially, is limited water content during crop vegetation period. And this is the main factor why we have so high fluctuation in the crop yielding. So the rain amount during the crop growing period is very, very much important if we are going to switch toward reduced or no tillage application. Another important thing is that we have 12 soil types here in Lithuania, and Cambi soil and Direct soil in this picture. There are two prevailing types of the soil here. And the conclusions are that Cambi soil is, by origin, is more fertile soil. If we look at the amount of soil carbon in the forest soil in the top layer, and we compare with ready soil. But if we look at the different tillage methods used in different soil types, it's clear that poorer soil, in this case ready soil, used to sequester much more organic carbon in the topsoil layer by using reduced tillage, compare the same tillage system in Cambi soil. And what is very important that we have in Cambi soil and in ready soil very soil organic carbon poor deep layers starting from 25 to 40 centimeters. And here one more gap of knowledge arises. How to increase soil organic carbon sequestration in the subsoil. And this is my last slide. And it comprises and conclusion and suggestion for the future research. Conclusion is in the title of the slide. No tillage is a halfway to reduce emission of gases from the soil. It's not the full way to solve the problem. It's only, unfortunately, halfway. And the big impression for me was obtained in the paper published in 2019, Soil and Tillage Research. And this paper was published by Claire Chenou and co-authors. And what is important to say, and I think for us is also very important, there are two ideas. The first one is subsoil horizon have lower soil organic concentration, and therefore the stock's potential is higher than topsoil. And the second conclusion is important, that there is a general need to access the potential for additional carbon sequestration in deeper soil layers. We know that organic carbon laying on very topsoil layer is biodegraded. It's natural process. And actually, if we want to lock the soil carbon, we should think about how to solve the problem for deeper insertion of the soil carbon into the soil. And for us here in Lithuania, where we have moranic soils, I think this will be the very important problem to solve. And as I think that AGP soil program, in which LAMPs take part, I think can solve and help to solve this problem. So thank you very much for your attention. And this is my last slide with hilly rolling relief with growing winter wheat. Thank you.
That's a beautiful slide. Thank you, Dr. Feyze. And I think you just raised some interesting questions and actually new research questions and the problems that needs to be solved. So if any of our scientists in the audience would like to collaborate potentially on the new projects with Dr. Feyze and other presenters, do get in touch. And I can feel there's a new research ideas and projects brewing. Well, to continue with the theme of the healthy soil, I would like to invite Chief Researcher at the Department of Ecology, Dr. Kęstutis Armolaitis, to take the stage. He has an interest in the forestry science, ecology, and environmental sciences. Kęstutis, we're looking forward to hear from you.
Can you see my presentation?
We can. We're good to go.
So, good morning, dear colleagues, and greeting from Institute of Forestry of Lamts. I will try to give you some message that soils are valuable, renewable environmental resource. The most sustainable soils are in the ecosystems of natural native vegetation. The soil organic matter and soil biota determine the sustainability of soil. The unsustainable soil use, the removal of organic carbon and nutrients should be compensated. And some words about physical and chemical soil disturbances that should be minimized, while permanent plant cover should be enlarged in agricultural land. This slide confirms that the soils are the most valuable environmental resources. You can compare the price of value of ecosystem, soil ecosystem services of soil with clean water, food, genetic resources. Impressive it is that soil importance, impressive is soil importance for food. 95% of our calories come from the soil, and the soil is full of the life. I decided to show you some general statements. First, that the quality, productivity, and sustainability of soils are determined by ability to accumulate organic matter. It's the same that for all living organisms. Second, the productivity and health of soil depend on the activity of soil microorganisms. Changes in the abundance of microorganisms will affect the vitality and ability of all other living organisms to respond to climate change. It's very important statement. And soil respiration is of microorganism. Soil respiration reflects the vitality of natural mineral soils and the activity of the mineralization of organic nitrogen, phosphorus, sulfur, etc. compounds. However, drainage of peatlands in our classification histosols intensifies the decomposition of P, CO2 and nitrous oxides emissions increase significantly. And in future, we expect to improve greenhouse gas emission factors from undrained and drained nutrient-rich peatlands in different land use, forest land, cropland, grassland, in the frame of Life or bulk project. But as you can see from leaflet of this project, in the agricultural sector of Europe, organic soils make only 3% of the total agricultural land, but are responsible for 25% of all agricultural greenhouse emissions. And even without any investigation, it's clear that drained arable land on nutrient-rich organic soils should be afforested or converted to perennial grassland, or even revetted. After revetting, CO2 emission is 0. Now some information about forest soils. Lithuanian territory is located in the forest zone. Because of it, I think for the assessment of soil quality on agricultural land, it is worth to select for the control the same soils of the same genesis in adjacent forests. We have compared soil microbiological biomass, carbon and nitrogen in mineral topsoil of arenal soils, can be soils, ready soils of different land use, arable land, grassland, birch, Scots pine, and obtained data showed that in many cases the highest this concentration were found in birch stands. It means, in my opinion, that in forest soils, by mineralizing organic matter of the forest floor and root litter, more carbon was accumulated by microorganisms, and it means that humidification occurs more intensively and carbon accumulates in slowly decomposing humus. The highest concentration of soil microbial nitrogen showed that the organic nitrogen mineralization was more intensive in birch stand than in arable land. Now, in another study, we evaluated the concentrations and stock of carbon and many macronutrients in above ground biomass of Scots pine on different age. We also assessed the potential removal of carbon and nutrients due to forest fuel. And of course, in this study, the soil nutrients were analyzed as well. And I think this slide is too complicated for presentation. On the other hand, it shows that in the calculation of total removals of above ground biomass and nutrients, we have included the removal during thinnings and sanitary fellings. The obtained data are summarized in this table, very important table. As you can see, the removal of carbon and nutrients with tree stem and crown could be extracted for forest fuel, was fully compensated with needle litter fall and fine root litter. The conclusion from above mentioned study. In cropland, organic carbon and nutrients often are continuously removed from the system, while in forest ecosystem, the above ground biomass are mainly removed in commercial forest periodically by clear cutting of mature stands, for example, every 100 years in Scots pine stands. And in our study shows that during a 100-year-long rotation period, until clear cutting, the removal of organic carbon and nutrients with above ground biomass in Scots pine stands were fully compensated by litter fall of needles and root litter. It's very important to do the same in agricultural land. Of course, we have big problems. Clear cuttings of forest stands essentially change the concentration of soil nutrients. However, the decrease of mean concentration up to the stable level for ammonium nitrogen were already fixed in 2-year-old clear cutting, another after only 4-year-old clear cutting. We have problem with dissolved organic carbon leaching from ski trails that are temporary, that are used for logistic equipment transport. In the frame of partnership project between Norway and Lithuania, we have evaluated soil organic carbon in surface mineral or peat layer up to the 30 centimeter of major soil groups in different use in Lithuania. It is the first study. And the soil sampling was done in the grid about 9 by 9 kilometers of National Forest Inventory permanent plots. It's necessary to point out that this grid covers not only forest land but cropland, grassland and wetland as well. And we found that in forests, of course, infertile sandy soil prevail, while in cropland and grassland, fertile alluvial soil, ready soils, and combi-soils. On the other hand, we have found in fertile sandy soils in cropland and grassland as well. And we think that such land with soils not could but should be afforested with productive Scots pine. In such poor soils, we can very productive Scots pine can grow. But I would like to point out that soil organic carbon stock could increase after more than 30-40 years after cropland afforestation of sandy soils. It means that not after 2 or 3 years, quite long period. It is for Nordic Baltic countries. Obtained data allow us to determine national values of soil organic carbon stocks for Lithuanian greenhouse gas emissions reporting. As could be seen from Table 3, these average stock values did not differ significantly in mineral topsoil of different land because of differences in bulk density. The concentrations of soil organic carbon reflect the condition of mineral soil more obviously. It is particularly worrying that soil organic carbon concentration in fertile combi-soils are on average about 2 times lower than in crops and grassland. The reason for this need to be clarified in the future. It's a very big problem, you can see. In 2020, we have repeated above mentioned survey with additional focus on soil microbiota. It is a project of Vytautas Magnus University. Project leader is my first PhD student, Dr. Jūratė Lenikovienė. And we found that in agricultural land, the strong prevalence of bacillus was determined. Maybe bacillus is trying to help plants to survive in an extremely changing environment. It is very interesting question because bacillus stimulate bacillus promote antifungal and so on activities. And in this slide, show that how permanent soil agrochemical analyses are important. The surplus of use of mineral nitrogen fertilizers could increase the leaching of mineral nitrogen to the groundwater, even in heavy textured soils, loamy soils. You can see forests mainly mineral nitrogen is mainly accumulated in forest in zone, root zone, while the leaching is awful. The last my slide, I collect some measure to reduce soil greenhouse emission and increase soil organic carbon from National Energy and Climate Action Plan of the Republic of Lithuania for 2021 and 2030. In this case, I would like to point out that I have the future of agroforestry, because agroforestry, cultivation of trees and shrubs, coppice and buffer strips, or even single trees on agricultural land, we could beautify the landscape, protect the diversity of flora, fauna, and soil biome, and increase accumulation of soil organic carbon in plant and soil, and agroforestry also reduce soil erosion and contamination of groundwater and surface water. So, thank you for your attention and patience.
No, thank you very much for very insightful and detailed presentation. I think the message is very clear that the forests are incredibly important to our survival as well, and for the sustainability of our environment. And if you have any questions to any of our presenters, please do put them in the chat box, and our presenters and Dr. Amrulaitis will answer those. And now, to continue with the theme, I would like to invite Chief Researcher Dr. Danutė Karčauskienė, who has an interest in soil physical state optimization, soil acidity management, improvement on crop and growing technology, to do her presentation. We're going to give you a few seconds to share your screen and presentation. See double of myself. I think we're more interested to find out about your amazing presentation. Again, just a reminder to all our participants, don't be shy. This session is for you to brainstorm ideas, put them in the chat box, and our presenters will answer them as well. So be active, because this session and information is as well for you.
Do you see my presentation?
Yes, I can see your presentation. If you could minimize the Teams window, because I can see myself.
Yes, I can do maximize. You see now and listen me?
I can hear you, and we can see presentation. If you could make a presentation. Perfect.
Yes.
All working.
Sorry for the techniques problems,
okay.
And I would like to make my presentation. It's my pleasure to make this presentation, which I would like to start with some statements about the soil. The soil is playing central role in achieving the sustainable development goals by 2030. Soil, together with air and water, are the three elements to address the zero pollution in Europe, and healthy food from healthy soil is one of the objectives of the Farm to Fork strategy. So to achieve this important goal of the European Green Deal, there is the need to implement means to preserve soil quality and limit soil contamination. So I would like to show you the scale of soil pollution in Europe. You can see in two figures that the potential contamination and identified contamination in Europe. It's belong from the country, but take part in this extrapolated data, and we see that the sites, polluted sites, is very, when the net is very high, and the sites, remediated sites, is net very low. Where you see that the main polluted areas in the city is main commercial areas, residential areas, industrial areas, as well as highways, but it is without agriculture. We know that in the agriculture, a lot of pesticides and fertilizers, chemical fertilizers, are used, which have many different varieties of pollutants. In the figure on the right, you can see various contaminants that affecting the soil contamination. One of them is heavy elements. About that I will talk in this presentation a lot. The situation about the soil pollution is the same like in Europe. You can see we see the net of the pollution hotspots in Lithuania, and this is without the agriculture, as I said before, but you have that the very dense network, and the main pollutants are oil and oil products, pesticides, and the heavy metals make about 9% in Lithuania, but the more in Europe. You see in the right in text that about 11,050 hectares land area can be contaminated by pollutants, and over 2,000 oil contaminated sites in Lithuania, including gas station, oil products storages, railway depths, oil pipes, and other. And the average cost of treat 1 hectare of polluted soils is about 6,000 euros. It is very expensive soil. So the technologies to remediate the contaminated soil is very useful today, and we can use many methods to treat to remediate the soil from the pollution. There are two main ways: in situ and ex situ. In situ, we can use a lot of methods, biological, thermal, physical, chemical, and combined. The thermal, physical, and chemical methods are very expensive, and in fact, some of them can be even more damaging to the integrity of the soil system than the contaminants himself. Such methods may result in strong adverse impact on soil functioning and on soil biodiversity. So, biological methods are ongoing methods and related with the Green Deal and is with green technologies in environment. You can see two methods: bioremediation and phytoremediation. Bioremediation is related with the addition to the contaminated soil of living cells. It is microorganisms, and biostimulants is to change the environmental at the rhizosphere, of the plant rhizosphere, to favor the growth of local microbial populations and increase its synergy effect with the plant roots. Phytoremediation is another remediation method where the plants can be used. Phytoremediation were several methods: phytoextraction, rhizofiltration, phytolyzation, phytodegradation, and phytostabilization. Related to the remediation of soil from heavy metals, the best of them is phytoextraction and phytostabilization. It is mechanisms, different mechanisms. It is for phytoextraction. It is hyperaccumulation in harvest part of the plants during the translocation from the plant root to the stems, leaves, and fruits. And phytostabilization is complexation of pollution, heavy metals, to the roots and not translocate into the stems and leaves. You can see different pollutants and different plants which can be used for this purpose. I would like to show some advantages and disadvantages of phytonumbination method. On the left, I would like to show advantages. First, in the red color, environmentally friendly, cost-effective, and aesthetically pleasant. Metals absorbed by plants may be extracted from the harvested plant biomass and then suitably recycled. Phytoremediation can be used to clean up large variety of contaminants and in the large areas. And the main disadvantages. This method takes time. This method can make a potential risk to the food chain in animal feed upon translocation, the pollutants from the root to the stems, and hyperaccumulative plants are low biomass. So it is a real problem, and it is the problem that make decisions the genetic science. I will to speak about the improving phytoremediation potential. I would like to begin from the rhizosphere, because the rhizosphere plays a significant role for improving this phytoremediation potential. Because rhizosphere is known to affect the heavy metal mobility and availability into the plant through release of chelating agents, acidification, phosphate stabilization, and redox change, and have potential to enhance phytoremediation process. It belongs from the rhizosphere. From the rhizosphere, during translocation, the pollutants goes to the stem, to leaves, and the measure size of the metal sequestration are the vacuoles or root cells. Heavy metals can be accumulated in various plant organs, roots, stems, leaves, seeds, and fruits, and this process belongs from the translocation heavy metals and our pollutants from the roots to the stems and leaves. What is the plant's hyperaccumulators? And what remarkable accumulation of soil heavy metals is three main aspects. This hyperaccumulator plants must to be able to hypertolerate high levels of trace elements in the root and shoot cells. The second, plants like Alyssum must have ability to translocate an element from root to shoot at high rates, and plants' rapid uptake rate for the element at level which occur in soil solution. For example, Tlapsi requires much higher solution zincum concentration and can concentrate 100 or 300 milligram per kilos in his biomass, when in normal plants is only 10 times concentration is lower. Where you can see the plants which differ from the 2 points, from the level of tolerant and hyperaccumulation. From the point of cleaning the soil from pollution, from heavy metals and from oil pollution, it's the better traditional hyperaccumulators and the plants which can tolerate high concentrates of heavy metals. It's the best way to clean the soil from the heavy metals and our pollution. The plants which can tolerant and accumulate heavy metals is not very useful for the cleaning of the polluted soils. Where you can see the various plants which can to accumulate different heavy metals, and one of them can, like Helanthus annus and other, can to accumulate in his underground and overground biomass a lot of heavy metals, 3 or more. The phytonumbination potential belongs from a plant physiology, and as well it belongs from the soil in which the plant is growing. There are many factors that can affect the phytonumbination potential. You can see with pH, redox potential, clay content, organic matter, cation exchange capacity, and nutrient balance can change the phytonumbination potential. We know that if the plant wants to accumulate a lot of heavy metals, these metals may be available in the soil. So the pH must be at low level, and the redox potential will be lower, and in the sandy soils the accumulation will take part better than in clay soils, and other, you can see in this, where other factors can influence the phytonumbination process. Phytonumbination process, as I said before, belongs from the pedoclimatic conditions in which this process take place. We have this moment where take place in the project. You can see in the left. The project aims is to increase the use of green technologies in order to decrease pollution with heavy metals discharge in South Baltic area and create innovative plant-based phytonumbination technologies and methods to clean polluted soils. Our region is Western Lithuanian region with acid retisols. And to determine accumulation of heavy metals in plant biomass, topsoil and enzymatic water, we are investigating, and our group we can see in the top. Where you see that we make 2 experiments in the field and in the controlled conditions. Controlled conditions is light and temperature. And today I would like to present you the data of 2 plants which are used for cleaning the soil contaminated by sewage sludge, artificially contaminated with sewage sludge, and 2 plants, buckwheat and cup plants, buckwheat annual plant and perennial plant cup plant. And schema you see it's without sewage sludge, and buckwheat was used 15 tons per hectare sewage sludge, and in cup plants the sewage sludge rate is larger, 45 and 90 tons per hectare. Sewage sludge was taken from 2 places, from large city Klaipėda and from smaller city Šilutė. And what I would like to pay your attention that in the sewage sludge there are a lot of nutrients and organic matter. In total phosphorus and organic matter is about 65–60%, and total phosphorus is higher in Klaipėda. In sewage sludge from Klaipėda, and a lower amount in sewage sludge from a small city. And total nitrogen is high concentrations in both sewage sludge from both places. And there are a lot of heavy metals, especially of zinc and copper. The data shows that at the flowering stage in buckwheat, the concentration of heavy metals higher was in the roots, except the concentration of zinc, it was in the roots and the shoots. And in another stage, maturity stage, when the heavy metals translocate from the shoots, from the roots to the shoots, the increasing in the stems, the copper and nickel and zinc, where you can see. And related to the biomass of yield, you can see that the highest amounts of chromium and nickel was obtained in the steams at the flowering stage, and the yield and in the soil with savage sludge, and it belongs from the highest yielding in the soil with the incorporation of savage sludge, like material with nutrients and with higher amount of organic carbon. Another Kaplan's data shows the largest concentrations of nickel and zinc was in the soil treated with savage sludge, highest rate 90 tons per hectare. And if related with the yielding, we see that the highest concentration accumulated in the dry matter of overground biomass was accumulated in the plants which grow in the soil treated with savage sludge both rates, and zinc and copper. And I would close without conclusions. I would say very shortly, the plant's ability to accumulate heavy metals can be controlled, and it's belong from the plant species and varieties, type and concentration of pollution, belongs from the soil texture, pH, redox potential, and organic carbon content, as well as by adding biostimulants like halides and humic materials and other. Thank you for your attention.
Thank you very much, Dmitry. That was very interesting in detail, as well as I think a lot of food for all of us. We have a question in the chat from Mohammed. He's asking, what are the examples of biostimulants that can help in soil remediation, along with the bioremediation, phytoremediation? What about organic amendment like biochar, biocarbon, which could also help in soil remediation as cited in literature? Your microphone.
I can to answer now. Yes.
Yes, you can.
Okay.
Now, yes.
Yes, I can see. I can see that halides and organic materials like humic substances, humic and fulvic acid as biochar and other, who has a lot of carbon, is very useful for increasing the phytoremediation process.
Okay, thank you. And just to say, there's a few more questions for you in the chat. So if after if you can stop sharing the screen, you can go to the chat and answer those questions. That would be absolutely great. Thank you.
Thank you.
Right. Our first session. Dr. Karchowskina, would you be able to stop sharing the screen and click X next to the mute button? That's the one. Thank you very much. So we are about to finish our first session, and I would like to invite Dr. Virmantas Povilaitis, Senior Researcher at the Department of Plant Nutrition and Agroecology, whose research interests are in peculiarities of plant biomass formation and modeling, to present our last presentation and the topic in the first session on biofortified and climate-resilient food and fodder production on marginal soils. Dr. Povilaitis, are you with us?
Yes, you can hear me?
Yes,
okay,
I can hear
I'll try
you.
to
Sharing.
You can see?
We can see it, yes, you're good to go.
Okay, hello. Thank you for this opportunity to present our project, and I want to talk about crop productivity on marginal soils. Shortly about my presentation, I just quick talk about the Food on Mars project, field experiments, greenhouse and Aquatron experiments, and remote sensing and crop productivity prediction. Usually we hear about increasing world population and increasing requirements of food production, but also we must remember that increase and for feed production, and new topic is renewable resources for industry and energy. And we want to look into marginal soils, what we can give them and what we got from them. So this project started last year and is participate 6 countries: Estonia, Lithuania, Poland, Germany, Belgium, and France. And in 4 countries we have field trials. In Poland, Germany, Lithuania, and Estonia. In marginal soils we grow spring barley crops in different treatments. The treatment scheme is the same in all countries, and we try to find differences of these soils and productivity in different agroclimatic conditions. In Lithuania, we set our experiment in Voke branch of lands. It varies sandy soils and depends in, can be named as marginal soils. And such type of soils, the problem of productivity is not only nutrition content, but also, and the main role plays water resources. And in our experiment last year, we installed the soil moisture measuring system in different layers, and all spring barley vegetation season was measuring soil moisture, and we see that in top of soil more moisture only when raining period, but after then the soil is dried very fast, and it could be one of the reasons why these soils are not very productive. In this project we use some amendments to increase the value and productivity of crops, and in this case we used selenium and silicon, and measuring chlorophyll index during the spring barley vegetation, we found that silicon much more affect the chlorophyll index earlier than others, than selenium, but selenium works little more longer. The grain yield is not like in middle of Lithuania in this fertilization level, but last year was water shortage, and it could affect these results. But when we use NPK fertilizers and foliar selenium application, we got little more grain yield more. How this amendments influenced the NPK uptake of crops. The largest part of nitrogen from soil was removed with grain yield, and interesting that potassium little more was taken with stem in treatment where I use NPK and selenium. Selenium is important for not only for food but also for feed, and we tried to investigate how much selenium after foliar application we have in different parts of crops, and the largest amount was in leaves and grains. Also, in this project, we have grassland trial, and where applied selenium, and also we have not fertilized treatment, and this difference is very big. Carbon accumulation in different parts of crops was investigated in spring barley. The results in different treatment is like similar. This slide borrow me our partner from Germany, Peter Schroeder, where they also have field trial with the same crop and the same fertilization rates. In Germany, they got little more grain yield. In greenhouse experiment in Germany was tested not only NPK and selenium and silicon, but also compost pellets for improving the soil. And this year we will use these pellets in our field experiments in different rates. And some results from greenhouse experiment there was 2 soil types, and tested NPK and pellets for different crop parts. The Aquatron experiment is done in Belgium, where is simulating the future climate. It is 2070 in marginal soils, and colleagues from Belgium share these slides and the results about their experiment. And the silicon amendments in this trial was more effective than without growing crops without amendments. Also use drones for prediction of crop yield. This photo is from our experiment in Lithuania. It's made from many separate photos. And after then was predicted the grain yield, protein content, and NPK uptake at different growing stages. During the spring barley growing season, we have 6 times drone flights under our field trial, and after then we got these results. Nice. Verification of the estimated results of drone flights. It is looks very nice, but it is only from 1 year, and it is maybe not correctly to do some conclusions from 1 year, and we will wait the results from this year when we have much more treatments different, and we have much data from field trials. So for future, we will, as I mentioned, we'll use pellets of compost in different rates, without nitrogen fertilizers and with nitrogen fertilizers, different NPK rates, to get more detailed information about crop productivity in marginal soils. So, shortly, all. Thank you.
Thank you very much, Dr. Povilaitis. Can I just ask you, so with your experiment, and we will wrap up our session after this question and answer, while we know that obviously to have a healthy soil, and we heard a lot from all our presenters, we need a lot of work and input and soil management and forestation, other elements. So that's going to take years. And in the meantime, with the climate change, do you think, and are you positive that we can grow climate resilient food in the marginal soils from what you have seen so far?
Thank you for this question. In my opinion, we can grow, but need to find what type of crops and what technology we must use to get the best result and optimal for such type of soils and for surroundings and economic value and socio-economic value.
Mm-hmm. So the challenge and the objective is quite clear, isn't it? So we just need now to bring different experts on board and hopefully have a great research project that has an impact at the end of it.